So in this video, we're going to talk about how we will use the process of, well, it's called completing the square, but specifically we're going to do it for circles, but you can apply it to just about anything with a squared term. So it can be quadratics, or it could be any other type of conic section, like a parabola or a hyperbola or an ellipse, but especially circles. So we want to take something like this, which happens to be a general formula, okay, for any circle. It has an x squared plus a y squared in it, so it has to be a circle equation. And we want to change it into this, which is the standard form for a circle, where we can quickly figure out what its center is and radius. Okay, sometimes people refer to it as center radius form, but it's actually just the standard form for a circle. Okay, and we do that by using a process called completing the square. Okay, so we're going to talk about the 5 steps. Might be less than 5, but we'll write down 5 steps that we're going to use to take this general equation and write it in standard form. Okay, so using the same equation we just had, here we go. Here are your 4 steps. Oh, maybe 5. Step number 1, get the variable stuff by themselves. Okay, that means move the number, any numbers that we might have, to the other side of your equal sign, okay, in order to get the variables by themselves. So that's going to leave me with an x squared and a y squared and a minus 6x and a plus 4y. And that's going to be equal to positive 3 when we add 3 to both sides. Okay, so all the variables are on one side and the number or numbers are on the other side. Okay, our next step is we want to get your like variables together. Okay, so the x's are going to get together right next to each other, and the y's are going to get next to each other as well. Get like variables together. Boy, my pen is sketchy today. So we have the x squared and the minus 6x. We get that together. And then we get the plus y squared and the plus 4y together. And that equals 3 still. Okay, so then step number 3, the important step, is to add the squares. Okay, literally we're going to put 2 boxes into our equation. Let's see if I have enough room. So I have x squared minus 6x, and I'm going to add in a square plus a box right here. Okay, after the 6x. And then I continue on with my y stuff, so plus y squared plus 4y. And it also gets a box added to it. Change colors. And that needs to equal 3. But as we learn in our younger grades, if I add something to the left side of an equation, I also have to add it to the right side in order to stay balanced. Okay, to stay mathematically equal, what I add to the left, I also have to add to the right. So I also add 2 squares to the right side in order to stay balanced. So step number 3 is adding the squares. Now here's the most important part. What goes in the squares? Okay, so numbers do in fact go in there. One specific number in particular. And that is the number that will make this thing into a perfect square trinomial. And the number that will make this into a perfect squared trinomial. Because what we're going to want to do is factor this, okay, with a special type of factorization. Now, that number that goes in there is half of your b term, so b divided by 2, quantity squared. Okay, we could add whatever number we wanted to, but we want to add this special number that makes this a perfect square. So now if you remember from Algebra 1, a general quadratic is ax squared, so a is the coefficient of x squared, plus bx plus c equals 0. So when I'm talking about the b term, I am talking about the number in front of your single variable. So for here, that number would be -6. So the number that goes in the box, -6 divided by 2 squared. That's the number that goes in here. -6 divided by 2 is -3. -3 squared is +9. So I'm going to add 9 in both of these pink boxes. Okay, half of -6 squared. And now I'm going to do the same with the y value. So 4 is my b value from the y equation. So 4 divided by 2 squared is 2 squared, and 2 squared is 4. So I add 4 in both of these blue boxes. Okay, that is the most important part, is now we have made this into a perfect factorable trinomial. Okay, and our next step is to, of course, factor. Okay, I'm going to do it on this line right here. So we're looking for numbers that multiply to give us 9 and add to give -6. So let me do it over here on the side. Hopefully you can still see it. What numbers multiply to give us 9 and add to give -6? Hopefully your brain is telling you that those numbers are -3 and -3. Product is positive, sum is negative. So this gives me an x minus 3 as one factor and an x minus 3 as another factor. Now, of course, mathematically, when we have two of the same factors, we write it as one factor squared, which is exactly what we want when we're writing down our circle equation. We want to have something squared. So x minus 3 squared. Okay, by the way, after a while you'll get to notice this, but if there's a negative in here, you have a negative in your factorization. -6 gives you a -3 factor. Plus, what numbers multiply to give you 4 and add to give 4? 2 and 2, so this will be y plus 2, quantity squared. And then on the right side, we have 3 plus 9 plus 4, which I hope is 16. So there is your standard form for a circle, where we can quickly say the center is +3 and -2 from the y value with a radius of square root of 16, which is 4. Okay, so these are your 5 steps when you want to take a general equation and write it in standard form for a circle.